Hey guys, this is Coach Lowe, and we are talking a little geometry today. We're in Chapter 5, Section 2, Medians and Altitudes of Triangles. So 5.2, Medians and Altitudes. Whoop, whoop. Everybody's excited? I know I am. So let's get started. All right, so first of all, let's talk a little terminology. Median of a triangle. A median is going to come from a vertex and it's going to hit the opposite side right smack in the middle. All right, so it's a segment that comes from the vertex and it's going to connect the vertex to the middle of the opposite side. So the vertex to the midpoint of the opposite side. I bet you could draw a picture without me even helping you. So why don't you go ahead and try that? Just draw a triangle and see if you can figure out where that median would be. All right, so if you've drawn yours, it would be right there. Now, we worked on perpendicular bisector, so when you think about this, you do know that you're going to have to construct, when we do constructions, you're going to have to construct the perpendicular bisector first, find this little point right here, and then connect it back to the vertex. I'm sure you probably already thought about that, but that's exactly what we're going to do, and that way we get the point that's right in the middle of that side. So how many medians could we have? Well, we could have three. We can have one coming from each vertex. All right, so of course, you know there's a cool name for where these three medians meet. You already knew that, I know. And that name, let's get the point here, is called the centroid. The centroid. So where those three medians meet is called the centroid. It is a point of concurrency. We talked about points of concurrency and we've looked at two already, the circumcenter and the incenter. And so now we're going to add to that the centroid. So here's the deal on the centroid. We have a 2-to-1 ratio on this centroid. This section from the vertex to the centroid is 2 times the section from the centroid to the side. So I have a 2x and x, which means this is 3x long. So think about that. If I know the red, if I tell you the red is 5, then the green is 10. If I tell you the green is 16, then the red is half of that, it would be 8. If I tell you this entire thing is 30, a great way to look at that, so let's say this is AB, and I want AC and CB, if I tell you that AB is 30, a good way to think about that is just go ahead and divide it into 3 segments, because really there are 3 equal sections here, X, X, which makes 2X, and X. So if you'll divide that by 3 and get 10, now I know this section is 20 and this section is 10. So 2-to-1 ratio on the centroid, the distance from the vertex to the centroid, and then centroid to the side. So hopefully that makes sense, and that works on every single median, every one, all 3 of them, and it works all the time. All right, so let's try maybe a few problems. Oh, let me give you one more thing before we move to the next problem. Let's talk about median. Let me add a page here. Let's talk about altitude. All right, so the altitude of a triangle is a segment that comes from the vertex and it's perpendicular to the opposite side. Perpendicular to opposite side. Now I've heard this before. Where do we use the altitude? Can you guys think of where we would use altitude? You've used it this year even. The altitude can actually be on the outside of the triangle or the inside because it measures the height of the triangle, doesn't it? Altitude measures height of the triangle. So if you remember finding area of triangles, sometimes they're on the outside. If your angle was acute, if your triangle was an acute triangle, and we were working with this angle, it came to the outside of the triangle. So this is the altitude. So AD would be the altitude or the height of that triangle. Right? Where the 3 altitudes would meet is called the orthocenter. Right? Where the three altitudes meet is called the orthocenter. So you can see sometimes they would be on the inside and sometimes they would be on the outside. Sometimes you have to extend your lines. All right, so where they meet is called the orthocenter. All right, so we're going to put all four of these together. Now we've looked at four, right? We have perpendicular bisector, angle bisector, median, and altitude. So we'll put all these together at a later time and kind of compare all of them. But let's just work some problems with these two guys right here. All right, so let's start with triangle PQR. And it tells me that NQ, well, what is NQ? Is it a median or is it an altitude? So looking at this, it's coming from Q, coming from the vertex, which so does the altitude. But as I look, it's hitting here. That's the midpoint. That makes this a median. All right, so I see that PN and NR are congruent. So I know that NQ, this whole thing is 6. All right, so now think about this. 6 divided by 3 is 2. I know that KQ is 4, 2 times 2, and I know that KN is 2. Remember, 2 to 1 ratio, right? So there's one of those and two of those, 2 to 1 ratio. This is the longer one. All right, let's see what else I know. PK is 4. If PK is 4, let's divide that by 2 because it's a 2 to 1 ratio. I know that KM is 2. Well, this is fun stuff. What else do I know? Let's see. RK, I missed that one. RK is 3. If RK is 3, what's KL? Half of that, right? So we divide 3 by 2 and we get 1.5 or 1.5. All right, so KL is 1.5. All right, let's see how much stuff we can fill in. We already found KM, it's 2. We already found KQ, it's 4. LK, we already found it, it's 1.5. All right, LR, we have not found that. So LR is this whole thing. So 3 plus 1.5 is 4.5. Whoop, whoop. We are rocking now. NK, already found it. It's 2. PM, this whole thing, well, we can find it now because it's, excuse me, 4 plus 2, and we know 4 plus 2 is 6. All right, so let's keep rolling with this. In triangle STR, H is the centroid. EH is 6. DH is 4. And this whole thing SM is 24. All right, so let's fill in the rest of this. So let's start with EH. If EH is 6, then this is a 2 to 1 ratio. This is the 2 part. This is the 1 part. So 6 times 2 is 12. So that whole thing would be 18. All right, so what do you think HT would be? I'll let you fill that in. You can pause the video, fill that in, and you can figure out this one for SM also. Remember, it's in thirds. All right, so if this is 4, 4 times 2 is 8. If SM is 24, 24 divided by 3 is 8. That means this little section is 8, and this long section is 8 times 2 or 16, and those add to be 24. So we're good to go. All right, so SH is 16. HM, where's HM? There it is, 8. TH, 8. HR, 12. Let's see, what else could we do? How about TD? TD, this whole thing, is 12. And then how about ER? So this whole thing, 6 plus 12 is 18. All right, so let me go back to TD real quick. TD is here. TD was 8 plus 4. That's how I got 12. And then ER all the way across is 6 plus 12 is 18. All right, hope that makes sense. Let's see. I think that's probably all that I want to talk about this time. And yeah, we can look at some altitudes when we talk again soon. All right. So guys, remember there are 4 things that we're looking at in these triangles. All right, so we looked at medians and altitudes, and previously we looked at perpendicular bisectors and angle bisectors. 4 points of concurrency. we'll put this all together and kind of get a little review going in the next couple of days. This is Coach Lowe, and I'm out.